Hi students, coming to our next topic, that is B trees. So this is one of the important topic while exam point of view. So in the previous videos we had seen the single level indexing. Actually the indexing is of two types, single level indexing and multi-level indexing. So in the previous video, I explained about the single level indexing. The single level indexings are the primary indexing and cluster indexing and secondary indexing. Whereas multi-level indexings are B trees and B plus trees. So I explained the single level indexing with example also in the previous video. So let us see what is the difference between the single level and multi-level. Single level means only you are having the index file which will help to search the record very quickly. So this having the key value and the block pointer, and you are having the data file. Okay, data file. So each divided into blocks, data files will divided into blocks. Okay, so these are the block pointer 1, block pointer 2, block pointer 3. So here you are having the 3 block pointers, each block having the records. Okay, so here the block pointing, it's pointing to the blocks. This is the single level indexing. Only one level is there. Directly index file is communicating with the data file. Whereas coming to the multi-level, so here the multi-level, you are having the data file. So data file is having set of fields, and each field having a set of records will be there. Those records will be divided into blocks. So block 1, block 2, block 3, like that. Okay, so here you are having the index file. This is the index file. Suppose you take, so this is the main file, you call it as a root. So here only you are having one particular key and one particular block pointer. So this is the main the database is accessing here. With the help of this, it is going to be search the files that are present in the data files. Okay, that are present in the disk. Okay, so that index file will help in searching the file in the data file. So in the single level indexing, you are having a sequence of K1, BP1, K2, different keys and different block pointers, BP2. So pointing to this thing. Okay, block pointer 3. Like this in single level. Whereas in multi-level, first you are having the root node that consisting of only one field. Okay, this pointings to one of the entry in this index level. So this you call it as internal node. This is also having the key values and block pointers, like that. Okay, so these are all the records. So these records will again divided into block pointers, blocks. Block 1, these two records comes under one block. These two records are comes under one block. Okay, so again this will be communicating with another field that you call it as a leaf node. So this particular block is communicating with one block, that one record. So that record is present in another block. This block is communicating with here, and here it's having set of records in each block. Okay, so like that. So here you can see different levels are there. This you call it as a multi-level. So instead of communicating directly the index file to the data file in the single level, here in the multi-level indexing, first the root is communicating with internal node to leaf node to data file. Okay, so what is the advantage here? So here you you will have so many of index file records, means so many records should be there to communicating to the data file. So for each entry, each data file will be communicating. It points to the blocks. So each entry in index file is pointing to the block, whereas here only one entry is first pointing to the internal node. Here the two entries is pointing to one internal node, okay, one block pointer, and these two entries are pointing to the one block pointer. Okay, so here it is decreasing the size of the whatever the index file that is accessing by the disk, that will be reducing. Only the limited number of fields will be there in this index file. Okay, so this is the multi-level indexing. Okay, so the main points in multi-level indexing is it consisting of node pointer, or you call it as a node pointer or block pointer. Okay, so the multi-level indexing consisting of a node pointer or a block pointer which points to that particular block, and it have a record pointer. Okay, so record pointer, a record pointer points to that record where the data is exist. Again, this record pointer, it points to that file, that record where the data is present. Again, here to here. So the exact main data will be present in here, the data file. Okay, so this multi-level indexing consisting of record pointer or block pointer or record pointer. So let us take, always the block pointer is less than that of record pointer. How you can say? Okay, so actually the block pointer size is suppose 6 bytes. Okay, suppose this is the 6 bytes of size. Okay, so to reach to that block, it takes 6 bytes. Okay, so but somewhere the data is present in somewhere in this block, means in the you are having 4 records in this block. In that the last record you are having the data whatever you want. Okay, so to reach that point, it has to add this size plus record pointer size. Suppose it 9B. Okay, so this completes it consisting of this, you call it as a record pointer. The size of the block and the size of the record to where that record is present, that complete you call it as a record pointer. So record pointer size should be more than block pointer, because first it reaches to the block pointer and it access to the particular record. Okay, so that is the record pointer. So this is about the multi-level indexing. So I said in multi-level indexing, B tree and B plus tree are the two examples. So let us discuss what is B trees now. Okay, what is B trees? Before going to know about B trees, what is a tree? Okay, what is a tree? So tree is just consisting of first root node, the first node whatever you call it as a root node, and below that you are having the child nodes. So you call it as a child nodes. Okay, and after that again you are having another two nodes. This you call it as a leaf nodes. So this is a basic concept you have to know while you are entering into the main topic. So the tree consisting of the root node, child nodes and the leaf nodes. Leaf nodes are nothing but no child. So after that you don't have another childs here. So the last nodes you call it as a leaf nodes. Whereas the child nodes you call it as internal nodes also. Internal nodes. The nodes that are present in between the root and the leaf, you call it as a internal nodes. So B tree. B tree. So let us start the B tree. So we had seen what is a tree. Tree consisting of root node and child node that you call as the internal nodes, and then after that you are having the leaf nodes. So B tree, at every level we have key and data pointer or block pointer. Okay, so for each level you are having the key and block pointer. Data pointer actually pointing to either block or record. So whatever the data pointer that is present here, this points to the block or to the record. Okay, so these steps you have to be noted. That is a B tree at every level we have key and block pointer. So let us take B tree of order M. So what is this order M? Suppose you take a B tree of order M. The size of the B tree is M. Okay. So the points you have to be noted it. Every node has at most M children. So here the order M means, okay, the size of the tree is M means it should be at most M children. Okay, it should be at most M children. You can't exceed more than M children. So it should be, the children should be also at most M. That every node has. So suppose this is the node. So this node is having at most M children. And this is at most M children. Like that. So next, a non-leaf node with k children contains k minus 1 keys. So what it means? A non-leaf node. A non-leaf node means children. So this you call it as a non-leaf node. So these are the leaf nodes and these you call it as a non-leaf nodes. Okay. Or you can take this is also a non-leaf node. Okay. So that non-leaf node with k children can contains at most k minus 1 keys. Okay. There should be only at most k minus 1 keys should be there. So I said each node is having the key and the block pointer. So that key should be, it should be at most k minus 1 keys. Next. So I'll take the example. If you see the example, then you will understand what these points means. Okay, just I'm giving the brief description about the B tree. After that we will take the example. So in that example you will understand what this k minus n and what this m, all this. Okay, so the root has at least 2 children. If it is not a leaf node. Okay, if it is not a leaf node means if it is not the last node, if it is, suppose if it is a root node, this root has at least 2 children should be there. Okay, and this has at least 2 children. Okay, at least 2 children should be there. So next, every non-leaf node except root node has at least m by 2 children. So what it means? So it is saying every non-leaf node except root node. So except, this is the root node. So except root node, every non-leaf node. So here the non-leaf node means this is the non-leaf nodes. So last one are the leaf nodes. So these are the non-leaf nodes. So these have m by 2. At least m by 2 children should be there. Okay. And next, all leaves appear in the same level. So this is important. All the leaves that are present, that should be appear in the same level. So these are the points about the B tree. So as said, what is a multi-level indexing? So multi-level indexing is divided in two types, B trees and B plus trees. So we are discussing about the B trees. So I have given the introduction about the B trees. Okay. So B trees consisting of at most m children, and it should be a non-leaf node with k children contains k minus 1 keys. Okay. And the root at least 2 children. The root has at least 2 children if it is a not a leaf node. Okay. Every non-leaf node except root has at least m by 2 children, and all leaves appear in the same level. These are the points to be noted in the B tree. Thank you.